Hello guys, now the question number 76. Question number 76, what will happen? So the key concept, key concept involved here is so factors affecting the SN1 reaction, nucleophilic substitution by unimolecular nucleophilic substitution reaction. So before understanding this question, we'll try to see the right side table which have made it easy for you guys. Now here we have given SN1 reaction factors as well as SN2. Here SN2, here SN1. Now SN1 means the order of the reaction is must be 1. That means rate of reaction depends only on the substrate. But in case of SN2, substrate as well as nucleophile both has to be depends. In this case, so here in the case of SN1, primary alkyl will not take place reaction except any resonance stabilizing effect is there, like a benzylic carbocation, right? So in that case, we can able to do the SN1. Otherwise, SN1 will not take place. But in case of SN2, very good. Why SN2 case? The reaction takes place via less hindered side. Secondary alkyl moderate will take place. SN2 also same moderate. Tertiary alkyl alide, it will be excellent. Why? So in this case, tertiary carbocation is more stable. You can keep it here. Tertiary carbocation is more faster than secondary than primary in this case. In this case, tertiary carbocation will not take place due to more steric hindrance is there. Living group both case is be important. Living group we can take in this order. I minus is more, then Br minus, then Cl minus, then F minus. Both cases same order. How much fastly the living group go, that much of fastly rate of reaction will occur. Nucleophilicity in the case of SN1 is not required because it does not depend on the nucleophilic, right? Depend only on the substrate only. But here most important, strong nucleophile will make the reaction very good in case of SN2. What kind of solvent we use in the case of SN1? Polar protic solvent. For example, H2O. We can use alcohol like this solvent we can use. In this case, aprotic. Aprotic means what happened here? So here hydrogen atom is not connected to more electronegative atom. For example, acetone. You can take no acetone. This one CH3. Dimethyl formamide DMF, dimethyl acetamide, right? Those things. Stereochemistry. Here, racemization takes place. Partial, inversion, partial, and retention. Retention 50% and inversion 50% due to both side carbocation will be means sp2 hybridized carbocation. So we'll be having the option to attack on either side, above the plane, below the plane. So that is the reason we'll get the partial inversion, partial retention. In this case, only one direction, backside attack will take place, only inversion. We can also say complete or Walden inversion. Walden inversion takes place in this case. Now, rearrangement. SN1 case, very common rearrangement. In this case, we can say no rearrangement will take place. Why? In this case, rearrangement will not take place due to no intermediate formation is there. In a case of SN2, no intermediate. If intermediate formation is there, then we can say rearrangement will take place. Eliminations common in the case of SN1, especially with the basic nucleophile. Only with the heat, only possible in the case of elimination. Right? So these are the main factors. So please try to note down your class notes. So it will be better way to answer the this kind of questions. Now you can see here. See here, SN1 reaction will not take place only three cases. Which cases? Like this. In case of halobenzene, halobenzene and vinylate. In case of vinylate, double bond CH, vinylic halide, right? So now, then third one we have bridgehead carbon. Then we have bridgehead, this case. So these three cases, SN1, neither SN2 will not take place. Why it will not take place in this case? in this case, what we have, in this case, lone pair available, in this case, partial double bond character is there. So carbon to halogen bond will not break out easily. Here also same reason, resonance is there in this case. Now in this case, Bred's rule will come. This Bred's carbon always should be sp3 hybridized carbon, not sp2 carbon, according to Bred's rule. Now we'll try to see here. So this reaction will not take place. This is possible. Why? Benzylic carbocation is forming, right? Benzylic carbocation is forming. Now, right? Benzylic carbocation is more stable than, right? Any other. Here, primary carbocation is forming. SN1 primary carbocation is rare and not takes place except if any resonance stabilizer is there. Here, primary carbocation. Here, secondary carbocation is there. But we can see here, benzylic carbocation will give you the best SN1 reaction. So, correct option is what we have. Option number 2 is the right answer.